Welcome all. Today I will discuss with you projections of solid. In today's lecture we will discuss solid, classification of solids, polyhedra, solid of revolution, position of solid in space, axis perpendicular to one of the principal planes, axis inclined to one of the principal planes and parallel to the other, axis inclined to both the principal planes. Solid. A solid is a three-dimensional object having length, breadth, and thickness. The surface of the solid may be curved or plane or a combination of both. Classification of solids. We can classify solid into two categories, polyhedra and solids of revolutions. Polyhedra. Solid bound by a plane surface is called polyhedra. So we can further subdivide polyhedra into two categories, prisms and pyramids. So prisms is a polyhedra having two identical ends or bases parallel to each other. The two bases are joined by faces which are rectangles. You can see in this diagram. Here is triangular prism, square prism. So here the bases are in triangular shape. One here, top, bottom here. Similarly in the square prism, you can see here square base and square top. So we have two bases of same shape. And these two bases are joined with the rectangular faces. Similarly in this and both you can check the same. Now is pyramid. So pyramid is a polyhedra having one base and a number of isosceles triangles faces meeting at a point called apex or vertex. A imaginary line joining the center of the base and apex is called axis of the solid. You can see in this diagram. Here is we have square pyramid. So one base and a apex point where these slant edges are meeting. So these faces are slant faces are triangular in shape. Same you can check over in this tetrahedron. So this is slant face. So is a triangular shape. So this is the apex point. Other is solid of revolutions. So when any plane figure is revolved about any of its sides, it generates a solid of revolution. You can see in this diagram we have three solid of revolutions: cone, cylinder, and sphere. So when we fix the edge of this right angle triangle here, so revolve about this fixed edge, so the shape generated is called cone. Similarly, when we have a rectangle, we fix the one edge and revolve this rectangle around this fixed edge, so we get the cylinder. Similarly, when we have a semicircle, we fix this edge, rotate or revolve about this axis or diameter, so we get the sphere. So these are called solid of revolutions. Now solid can be positioned in space in different positions, like we have number one is axis perpendicular to one of the principal planes. Second is the axis inclined to one of the principal planes and parallel to the other. And third one is axis inclined to both the principal planes. So let us discuss very first, that is axis perpendicular to one of the principal planes. So in this condition, the axis is perpendicular to the one of the principal planes. It is parallel to the other plane. You can see in this diagram here, the axis of this solid is perpendicular to the vertical plane. So you can see here there is a front view. So in such cases, axis of solid is perpendicular to the any one of the principal planes. The projection on that plane will show true size and shape of its base. So you can see in this diagram, as this object is that is axis is perpendicular to vertical plane. So here we are getting the projection in the front view. So this is the true shape and size of the object. So we have to draw this first, and after drawing the front view we will draw the top view. So when axis is perpendicular to vertical plane, the front view must be drawn first. So we have to draw this front view, and then top view is projected from it. So after drawing this one, so we will draw the top view. And when the axis is perpendicular to horizontal plane, so as in this diagram, axis is perpendicular to the horizontal plane, the top view must be drawn first. So we have to draw this one first, and after drawing this one we will project the front view. So this is the case of the axis perpendicular to the one of the principal planes. Next is when the axis is inclined to one of the principal planes and parallel to the other. So in these conditions, final projections are drawn in two stages. So we have to complete the projections in two stages. In the first stage, the axis of the solid is assumed to be perpendicular to the principal plane to which it is actually inclined, and views are drawn. So you can see in this diagram here, we assume the object is having axis perpendicular to the HP. So we have to draw this view first. After drawing this view, we will draw the front view of the object. So this we will complete in the first stage. So in second stage, the position of one of the view is redrawn to suit the given condition, and the other views is projected from it. As you can see in this diagram, after completing projection in the stage 1, we just incline the axis of the object to the HP as per the required condition. So after drawing this projection, so we will project the top view of the object with help of the top view of stage 1 and the front view of stage 2. So this is the required condition when the axis is inclined to one of the principal plane and parallel to the other. So in this case you can see this axis is inclined to HP and the axis is parallel to the vertical plane. In the third condition, axis inclined to both the principal planes. So in this case, we have to complete the projection in three stages. So solid is said to be inclined to both the plane when the axis is inclined to both the planes, or the axis is inclined to one plane and an edge of the base is inclined to the other. In all cases, final projections are obtained in three stages. In stage 1, axis of solid is assumed perpendicular to one of the planes and projection drawn. So as in stage 1, you can see we assumed object is having axis perpendicular to HP. We just draw its top view first. After drawing this top view, we project the front view from this projection. So in this way we just complete the projection stage 1. So after drawing this one, in stage 2, one of the view redrawn by making the axis inclined to one of the plane and projected the other view from it. So now in this second stage, we incline the axis of the object to the HP. So after drawing this projection, we project the top view of the object by using the front view of the object in the stage 2 and the top view of the object in stage 1. So in this way we complete the projections. Now in stage 3, one of the views redrawn obtained in stage 2. So in this case you can see here we just redrawn this projection. After drawing this one, we just redraw this projection at given angle, and then we project the projections in the front view to get the front view of the object when the object is inclined to both the principal planes. In this way we complete the projection, and this method is called displacement method.